So these are our formulas here, our double angle identities, sine of 2 theta, cosine of 2 theta, tangent of 2 theta. Okay, we just proved in Bell work the different ways that we could get those to be true. You don't have to necessarily be perfect at them, but they were really easy using sum and difference identities. Notice that cosine has 3 different ways of doing it. They're all the same. Okay, they're all exactly the same. They're just rewritten. We just proved the 1 minus sine squared theta, but we could have plugged in for sine and gotten cosine squared theta. It would have given us the same concept. This right here, you can use sum and difference identities to find these answers. It's like saying 3 times 3 or 3 squared. They both get you the same thing. You're doing 2 different operators, but you're getting the same answer in the end. Just a matter of which way makes most sense for you. All right, let's look at number 2 here. So it says, if sine of theta equals that, and I'm between pi over 2 and pi, find the exact value, and we are trying to find double angle problems. For each one of these things, we are taking the angle and we are going to double it. They told us up here some information about sine. So up here it says sine of theta equals 5 over 13. So again, just like yesterday, the best way to start this problem off is to identify my triangle, identify my x, y, and r. Fill in the information there that you need. Since sine of theta was 5/13, we knew my y was 5, my r was 13. Show me with your fingers, what'd you get for x? I'm seeing 12s. 12 is not the right answer. Why is 12 not the right answer? It's negative. The correct answer here, x is negative 12. We could do Pythagorean theorem. X squared plus 5 squared equals 13 squared. That's a Pythagorean triple. X is 12. Okay? But the reason it is negative is because of this guy right here. It says theta is between pi over 2 and pi. Which quadrant are you in if you're between pi over 2 and pi? You're in the second quadrant. Everybody good with that concept? Let's go to the next part. So sine of 2 theta. If you take sine of 2 theta, we are going to use our formula. So our formula says 2 sine theta cosine theta. There's our formula. We are going to plug in what we need. So 2 sine theta cosine theta means I'm taking 2 times sine times cosine. Find an answer. Don't use your calculator. Don't fall into the trap here. Sometimes students will multiply both top and bottom by 2. That's 2 over 1. So on my bottom is 169. On top, 2 times 5 is 10. Times negative 20 is negative, or times negative 12 is negative 120. There's my answer. Use that same concept. Find out what cosine of 2 theta is and what tangent of 2 theta is. Take a second with your neighbor and do that. There we go. Part B. Thumbs up, thumbs down, positive, negative. Part B. Thumbs up, thumbs down your answer. Should get positive. Let's look. I'm taking negative 12 and I square it, so negative 12 squared would be positive 144 over 169 minus 25 over 169. That one's pretty easy. 119 over 169. Boom. That is cosine of 2 theta. On the bottom, this one gets a little bit more fun. 2 tangent of theta over 1 minus tangent squared. I've plugged in some information already. Then it's a matter of doing it. On top, I'm going to multiply the 2 times negative 5, so I get negative 10 over 12. On bottom, I have 1 minus negative 5 squared would be 25. 12 squared would be 144. Just like the other day, we didn't like this when we were doing identities, so I'm going to get common denominators and add those together. So 1 would be the same thing as 144 over 144. So on bottom, I'm getting 119 over 144. On top, I have negative 10 over 12. I have this fraction divided by that fraction. What can I do if I'm taking a fraction and dividing by another fraction? Reciprocals. That's negative 10 twelfths. I'm going to multiply by the reciprocal, so 144 goes on top and 119 goes on bottom. I don't want to multiply that out, actually, so I'm going to simplify here. 12 and 144. Reduce that thing. I get negative 120 all over 119. It is practicing our 7th grade math skills. More than anything else today, that is what we're making sure we can handle. Questions with those? Flip it over. On the back side, the front side, we did double angle identities. On the back side, we're doing half angle identities. Like bell work, you could or like what we did in Bell Work, we figured out why those formulas work. We could have done that. I didn't think it was the best use of my time. In the top right-hand corner of your notes, there is a QR code to a YouTube video. So when I post this on YouTube, I'm talking about another YouTube video. It's very cool. But you could go to that video and then examine why these formulas work. We're not going to get real deep into that. Here are our different formulas. All of them are taking some angle and cutting them in half and telling you what the new value is. Let's apply this. So cosine of 15 degrees. We are using a half angle formula to find the exact value. So again, when we see the exact value, normally that means we're probably using some unit circles here, especially since I'm finding 15 degrees. We did cosine of 15 degrees the other day. We did that with sum and difference identities. We took 45 minus 30, and that got us that answer. We could also do half angle. What angle would I use to get 15 degrees if I'm cutting it in half using something on our unit circle? 30, yeah. This is the same thing as cosine of 30 divided by 2. It's the same concept. I took some angle and I cut it in half. So since I took some angle and I cut it in half, I can use my cosine half formula, which is this guy right here. And so this thing's going to be equal to plus or minus the square root of 1 plus cosine of 30 degrees, all divided by 2. And then really from here, this is, again, 7th grade math. How good are you with simplifying fractions? That's what we're working on. So this, if I simplified this, it's the square root of 1 plus cosine of 30 degrees is the square root of 3 over 2. I don't like writing the fraction like that because it throws us off. So square root of 3 over 2 all over 2. Super. I don't like having the two separate fractions, so I'm going to take this top guy and multiply it by 2 over 2. And I'm going to combine those fractions with one denominator. So my denominator on top is a 2. It's 2 plus radical 3 all over 2. Still pretty ugly. I need to get rid of the fraction over a fraction. What could I do here? What's going to happen to get rid of the fraction over a fraction? Yep, Drew. So if I multiplied the top by 2 and the bottom by 2, he's multiplying by 2 over 2. That's a legal move. If he multiplied that top by 2, those 2's are going to cancel. If he multiplies the bottom by 2, that is going to get him a 4 in our denominator because 2 times 2. We got that. I can't leave my answer like that. Why can't I leave my answer like that? There is a radical. A radical under a radical is okay. The bigger issue here is there is a radical in our denominator, and we don't like a radical in our denominator. That whole thing is square rooted, and so right now it's the square root of 4 on the bottom. What could we do to get rid of the square root of 4? Make it a 2. And so this is going to be my answer. Kind of. That's not my answer because it is not both plus and minus. It is either plus or minus. Which one? Show me thumbs up, thumbs down. Which one do you think it is? Is my answer plus or minus here? Carrington, why do you think it's positive? Cosine of 15. If 15 degrees, it's in the first quadrant. And if we're doing cosine in the first quadrant, it's got to be a positive answer. So this answer is positive. That is our answer to this thing. Again, we did this the other day with sum and difference identities. If we would have done this with sum and difference identities, our answer would have been this. The square root of 6 plus the square root of 2 all over 4. Although they don't look the same, if you type this into your calculator and type that into your calculator, they're the exact same thing. It is weird to have the radical 3 underneath another radical, but it works. You take 2 plus radical 3 and then square root that thing, and it'll get you the same number. A little bit strange, but more algebra than anything. Questions with that guy? Try sine of negative 15 degrees. Work with your neighbor and get an answer for that, please. Set it up very similarly here. I did cosine of negative 30 when I was doing negative 30 divided by 2. That's that's radical 3 over 2. It's minus. I multiplied that 1 by 2 over 2, so I could get common denominators. Now I have both the denominator of 2, so I wrote it together. To get rid of this 2 on bottom, I'm going to multiply this by 2 and that by 2. So I multiplied by 2 over 2. Those cancel. I get 2 minus radical 3 all over 4. I'm square rooting that whole thing. And so I can take the square root of 4. It's going to get me 2 minus radical 3 all over 2. So now just the numerator is square rooted. That is not my answer because it was plus or minus. Thumbs up, thumbs down. In the end, what's my answer need to be? Audrey, why does my answer need to be negative? Yep, I'm in the fourth quadrant, so why is it negative? The y value is negative. We're doing sine in the fourth quadrant because negative 15 degrees falls in the fourth quadrant. It's going to be negative. Everybody good to that point? Let's do one more together here. Looking at this last problem, it says if cosine of alpha is negative 3/5 and pi is less than alpha is less than 3 pi over 2, find the exact value. We're going to speed up these notes here at the end. Let's make this, we're just going to do tangent. That's the only one we're going to do, tangent alpha over 2. We just did the other ones a second ago. So just like before, we're going to start this guy off by doing x, y, r. I'm going to go fast here because we're running out of time. Cosine's negative 3/5, so that means my x is negative 3, my y is 5, my y is going to be 4. Thumbs up, thumbs down. What's my y value going to be? Positive or negative? Mackenzie, how do you know it's negative? It's in the third quadrant. If you're between pi and 3 pi over 2, you're in the third quadrant. And if you're in the third quadrant, your x and y are both negative. We're doing tangent alpha over 2, so my problem looks like this. It is plus or minus the square root. I'm dividing by 2. So it is that formula 1 minus cosine of alpha divided by 1 plus cosine of alpha. Plug it in and simplify it down. The number one mistake you'll make here is the ending sign. Think about it. We're setting this guy up. It's 1 minus cosine, so cosine's going to look like negative 3/5. On bottom, it's 1 plus cosine, so it's 1 plus negative 3/5. When I combine these together, obviously, I could multiply this guy by 5/5 and this guy by 5/5 to get common denominators. It's minus a negative. This is 8/5 on top. This is 2/5 on bottom because I'm subtracting. I don't like that answer because I'm got fractions over a fraction, and so that is the same thing as 8/5 times the reciprocal of that. I'm dividing by a fraction, so it's times 5/2. The 5s would cancel. I get an answer of 4, but remember that's not it. I just forgot to keep writing the square root and the plus or minus. Square root of 4 gets me 2. Thumbs up if you think that is a positive 2 in the end. Thumbs down if you think it is a negative 2. We are 0 for everybody because the answer is negative. It is a negative 2. Let's talk about why it's negative. This angle was between pi and 3 pi over 2. All right, so think about your unit circle. You started off between pi, which is like 180 degrees, and 3 pi over 2, which is like 270 degrees. What did we then do with that angle? We took a half of it. And so take any number between 180 and 270, including 180 and 270, and cut it in half. Which quadrant are you going to fall in if you take one of those angles and cut it in half? 2. You take 180 and cut it in half. All right, let's pick one in the middle, like 200. If I took 200 degrees and cut it in half, it'd be right here, 100 degrees. If you were doing tangent in the second quadrant, what's going to be true about tangent in the second quadrant? It's negative. Be careful with that. When you cut it in half, you got to think of where would that quadrant end up.